Here we go, made it to the last question of our practice test. Question 6, we're getting into average rates of change here. So the graph shows the total distance walked in feet. Now, there's a little typo here. I put walked in there twice. It should only be there once. So let's go again here. The graph shows the total distance walked in feet by a person as a function of time in seconds. So, as always, every time we look at a graph, we're going to pay really close attention to our axes, right? We've got on our horizontal axis, we have time in seconds. So our input, we're going to plug in how many time in seconds have passed. And for our output, this function is going to give us our vertical axis, the distance walked in feet. So question A, part A of this question 6. Find the average rate the person walked between 40 and 110. So the average rate of change is really pretty much the same exact thing as slope. We're just not going to sweat the bumps, the ups and the downs, right? Usually, for most of your math career, you've been looking at linear functions that just go in a straight line. But now we're looking at some data where they're walking pretty fast here, and they kind of go kind of slow on that stretch right here. They kept a constant rate here, but it's a little bit slower. And then they speed up a little bit, and then maybe they slow down, but they're still walking. And they slowed down some more, and then they got real slow over here. But you know what? We're not going to sweat all those little changes, this and that and this. If you're lucky enough to study calculus later on, they're going to be approximating these tiny little tangents to find out the rate of change at each and every moment on a graph or a curve. But we're not worried about that right now. We're just thinking about this. It's just like slope. So what is slope? Change in y over change in x. So let's write this formula here. Here's this little triangle is from the Greek alphabet. It's called capital delta. Delta, we use it in math and science for change. Change in y over change in x. And sometimes people call this rise over run. How much did our graph go up or down divided by how much did our graph move to the right? It's always moving to the right. We read our graph just like we read a sentence out of a book, from left to right. So we're always counting how much it went to the right. That goes in the denominator. That's our run. And our change in y, or the rise, it's how much did it go up or down. So there's a formula for this. Change in y over change in x. If we have 2 points, you're going to take the y value from your second point, or y2, minus the y value from your first point, y1. And that is going to give you your change in y. And in the denominator, our change in x, we've got the x from the second point, or x sub 2, minus the x from the first point, x sub 1. So let's get into it. What the heck is that? What's y sub 2, y sub 1? What's x sub 2, x sub 1? So in this particular question, part A, we're going from 40 to 110 seconds. So I'm going to plot these points on my graph, make sure I know exactly where they're at. So after 40 seconds, it looks like we were at approximately pretty close to 10 feet. We'd walked about 10 feet. This person walked about 10 feet after 40 seconds. So when we write a point, x always goes on the left, or in this case, our input, and that was 40 seconds. And on the right is the y value, or f of x, in this function notation that we're dealing with. Or maybe it could be d of t, distance is a function of time. So what's that vertical value? Let's just call it 10. It's close enough. Let's keep our math simple here with a 10. So this is our first point. On the left, we got x sub 1. And on the right, we got y sub 1. It's in alphabetical order. X on the left, y on the right. X comes before y in the alphabet. And the x portion of your coordinate comes before the y coordinate the y portion of our coordinate. Now, what about x sub 2, y sub 2? Our second point, they're asking about 110 seconds. So notice 110 is not labeled on my axis, but I'm not going to freak out. I'm just going to think, hey, 110 is like halfway between 100 and halfway between 100 and 120. So I kind of trace up to my graph. Let's say right there. That's a nice even number after 110 seconds. This person had walked 25 feet. They're moving kind of slow, but that's where we're at. So what is that? We've got x sub 2, comma, y sub 2. Here's my second point. Now let's plug these numbers into this formula. For some people, the formula can kind of get you into a confusing area. It might, in some cases, it might just be simpler to think, how much did my graph go up or down? That goes in the numerator, divided by how much did it move to the right in the denominator. But if we're careful, we can use this formula and plug these points in here. So y sub 2 is in that point, that second point. After 110 seconds, we were 25 feet. So we'd walk 25 feet. That came from y sub 2 minus where we started at that 40-second mark at 10 feet. And down here below that in the denominator, my x sub 2, we got to 110 seconds. And what we're evaluating, the portion that we're looking at, the average rate of change, we started at 40 seconds. So like I said before, it's just like slope, only we're just going to worry about the straight line between here and there. That's why they call it average rate of change. We're not trying to figure out this part and that part and the other part. We're going to make a straight line between our 2 points and measure the slope of that. So the change in y, how much did this thing go up? This person walked an additional 15 feet. 25 minus 10 is 15. And over a period of how many seconds? 110 minus 40, over 70 seconds. They walked 15 feet in 70 seconds. And there's our average rate of change. You can leave this as a fraction. You don't necessarily have to even simplify it. I guess you could probably divide the top and the bottom by 5 and find out that you got 5 over 14, or no, 3 over 14. But let's just leave it like that. I'm not going to simplify this because I want to see that. Look, they walked 15 feet in 70 seconds. That's going to help me see that average rate of change right there. And that is pretty much part A here. A good way to check your work is look at the graph. Did it go uphill? You want to make sure it's positive. This is positive 15 over 70. It's got kind of a positive slope from here to there, so that we know we're on the right track. That's part A. I'm going to make 2 more videos for part B and part C, so I can keep them short.